it's another class today, and I think previously we have kind of gone over a number of basic things, that uh, as a new person to Python, you kind of need to know um pretty basic stuff. And last last class we actually wrote, solve some problems, like creating a Python script that helps workers calculate their pay, their daily pay. Um, so when you go back and maybe watch those videos, and or maybe you're just studying on your own, I encourage you to make sure that like on your own time you're actually kind of like trying out those problems on your own, or maybe even creating a little more scenarios, because I can tell you for free that programming, it's not really about the the number of things you're able to learn, or number of classes you're able to go to and stuff like that. It's actually more about the practice that you build when you're going over those things on your own. And then you actually, those times, you take your time and you type in the code that I typed on your own, and then you just kind of type them and kind of run them and make mistakes. And that's actually the most important aspect of it, So try to do that, and try to do a lot of practice on your own. Remember that the whole goal of learning Python in 2025 is not really for you to be the best, Python programmer ever, so, but it's for you to have enough background knowledge to be able to compete. Obviously things are changing really fast, and people who are coming from a technical background already have an upper hand in whatever the future holds for all of us. So that's kind of the whole idea. So you want to spend enough time to gain that knowledge. And what's really important is the knowledge. You might not necessarily need to write all that code. And in 2025, to solve problems, you're most likely going to use some AI tool to do that. So, but without that background knowledge, it's all becomes worse, because like as soon as something goes wrong, you are completely lost, and it's gonna be very difficult to get back on track, because so many of the things that we used to do are now being wrapped into some other layers of softwares and engineering and solutions in form of AI. And if you have no idea what's going on behind the scene, it's kind of really a trick. It's gonna be a really difficult situation. So just focus on the knowledge. Don't think too much about um many other things that usually make people to fall back on their programming journey. Just focus on learning these things that we are talking about right now, without thinking too much about how you're gonna use it, and whether you're going in the right track, or whether you're maybe whether you're not maybe you're wasting your time and all of that stuff. Just give the time required. Technical background is gonna be pretty. It's gonna be you know uh pretty how do I even put it? Like, it's gonna be something that is gonna be very hot in the recent in 2025. And if you don't have it, it's literally gonna be what um separates you from the rest. So I would say just focus on the things we're talking about, no matter how simplistic, no matter how I don't know, maybe too much time we are taking to go over them, right? Okay, so today we're getting into something called conditionals in Python. And if you're joining us for the first time, don't worry. You don't have to, you don't have to understand everything I say today. You might need to go back and look at some of the other videos before you actually get it, but it's kind of building from where we stopped. And today we're getting into something called conditional statements in Python. I'm going to share my screen. Okay, first of all, let me just share the entire thing and kind of go over this routine one last time for those guys who are joining us for the first time. So you see, we have already gone through setting up Python on our computers, and most of us are already set up, but we had a whole session on that, and it's setting up Python, VS Code, Git, GitHub, and all the other things we needed to kind of, get onboarded properly into the program. And if you have Python set up at this point, you're good to go. Like we did before, one way to open up Python on your computer is to, kind of open it interactively. If you're confused about what I'm doing, I have just opened up my terminal on my computer, and it's pretty a simple tool that I have on my laptop. And if I'm on a Mac, so I can always just find it here. And I open up my terminal, right? And then I can actually go ahead and open up Python on my laptop. I can interact with Python this way, but this is just one way. We're not doing it this way. The better way to do it is to use a code editor called VS Code. And with this editor, we're able to write our code into a file and then save it on our computer and then run it with Python. All right, so that's the preferred method to use Python. And today we're getting into conditional statements code in my VS Code, like this, and just so that we can understand how conditional statements works and why they're important in Python. Okay, so having gone through all that, I'm gonna stop sharing my entire screen right now, and I'm gonna share just my VS Code. Let me know if you can still see my screen. Yeah, just let me know as soon as you can see it. All right, thanks, Eugene. Okay, so today, like I said, we're going to talk about something called conditional statements in Python. So you see, previously we have done things like this. We've done things like this in Python, and this is a perfectly valid Python code, Python application, even if you put it like that. But it does the simplest thing, right? It takes 5, which is a value that we have. Maybe 5 is something, maybe 5 means something to me. Python doesn't really know that. Maybe 5 is the number of fingers on my hand, for instance, right? That's 5 fingers. So, but I kind of want Python to remember that, so I tell Python, hey, I got 5. It's something, it's some number, and then I give it to Python, and Python goes, oh, okay. What do you want me to do with this value? I want you to remember it. So Python goes to my laptop, and then it makes a storage location, it marks it as X, and then it saves 5 there, case closed. And then we can actually run this code, but nothing happens, right? Then I tell Python to print the same number x. So now Python goes back to that location where it saved this number that I gave it originally, and it called that place x. So it goes back to that place and then it prints whatever is in there, and that's how we have Python. Also, we have 5 on the screen. Fine and good. No, this is perfectly normal Python code, everyday normal code. But this is this is kind of like walking on a straight line. It does line 1, it does line 2, and we can continue like that. We can keep writing stuff all the way to line 1,000 or even 1,000,000. Some codes are actually millions of lines of code. But it can keep going on a straight line, and that would still be okay, right? Because if we just want to be saving numbers and printing them, and that's really all we want our computer to do, it's comfortable doing that, right? Our computer has Python installed. It can keep doing that every day continuously, and nothing changes. But sometimes we kind of want our computers to make decisions by themselves, So it's kind of where things kind of start getting a little bit interesting, because for a computer to make a decision by itself, it has to. It's actually some kind of a smart thing. It's kind of like walking on a straight line, and then you get to a junction, and then you now have to decide whether to go right or left. So it's the same thing. Our computer is going on a straight line. You give it this line of code, it runs it perfectly. Give it the next line of code, it runs it perfectly. But the next line, it gets to a junction, and then it has to decide, should we go right or left, right? So that's what conditional statements are in Python, or in programming in general, actually. So sometimes there are many reasons why you want your computer to, kind of take decisions on their own. So it's what makes the way that we just explained this code right now. This is something called sequential execution strategy, whereby Python just takes your code sequentially and then executes them, right? Yeah. So, but computers, we don't just want them to follow instructions mindlessly and just be going on a straight line. So sometimes we want them to use their own ability to make decisions. So that's where conditionals come in. Imagine like you're driving, for instance, and then you get to you're going on a straight line, and then you get to a junction, and you need to decide on which way to turn. If it's a computer and it's going on a straight line, it's probably going to crash into somebody's house. So, but it takes some level of intelligence to be able to move the vehicle in a certain direction, and that's where conditional execution comes in. So do you turn left, do you turn right, do you keep going and jam into that next compound right in front of you? The choice depends on some conditions. And in Python, the simplest way to express this is something called an if statement, right? So this is a completely valid code, and now Python gets to a junction and we want it to make a decision. So we use this word if. If is basically an English word. I like to think of coding in Python actually as speaking English, except instead of speaking the general English, you have to speak in some coded English that, kind of like we have shortened everything we used to say, and we shorten them into different codes that have meaning so that we can say much more without using so many words, kind of. That's how we look at programming languages. So instead of telling Python things in simple English, we code it in a way that we can only say like if, and Python knows that, oh, okay, this is a junction and I have to make some decisions, right? So imagine we are still working on this, and then we have gotten to a junction and we just don't want to continue to line 3. Line 3 is a junction, and we only want Python to continue if certain conditions are met, right? So we would, I'll probably do something like this. If x is less than 10, print x. I'm going to remove this print statement here so that we can use only this one. Okay, so if I go ahead and I run this code, okay, we get into an error, and that error is in line 2, and it's a syntax error, and it's common thing that can happen to anyone actually. So just know that it's normal, for instance, for you to write a completely normal code and then it still fails. So but right now I have to kind of go in and try to figure out, and just looking at this, I think there's a little bit of space between this guy and this guy. Okay, maybe that's maybe that's the problem actually. Just to make sure that we are indenting properly, I have rewrote those lines to, and if I go ahead and I run it again, we still get issues. Okay. What if we do this? We're still gonna run into some issues. Still run into some issues. Oh, okay. Tracy's having some low battery issues. Okay. So that is why. Yeah. So it looks like we have made some mistake right here, and instead of typing the correct thing, I said if less than 10, right? And it's my mistake, is there needs to be x here. So that's the problem we had, and most times you're gonna get issues. You're gonna run into issues, and the first thing that is gonna come to your head is usually like, what's wrong with this computer? So but most of all the time it's always our fault. So I kind of need to go back and pay attention to the details, to kind of catch this. But now I've seen where I made a mistake, and if I go ahead and I run it, it should run fine. Okay, so I'm gonna clear this. And now the point here is we are going on a straight line, and here, let me still put this print statement. we're kind of going a straight line. First of all, we assigned 5 to a variable named x, and then we printed it on line 2. And then in line 3, we now hit a junction. And then now Python has to decide, make a decision by himself, right? So here we are telling Python to give it a value 10. You said, okay, what do you want me to do with this value? You said, compare this value with x. If x is greater than 10, that's when you can print x. So how it works is that Python runs this line, and it reaches here. Whatever is here with an if statement, and if statement will evaluate whatever you give it, and then it will produce true or false. So here, what Python knows is that we are telling him that if this evaluates to true, then go ahead and run anything under it. So we can print x, we can do some other things. Maybe we can print yes, as well. And then at the end of it, we can print done. So right now we have done something. We have written a code that uses a conditional statement to decide whether it can print these things or not, right? So in this scenario, x is 5. Here we are printing x. And then in the third line, we are checking if x is greater than 10. Of course, x is not greater than 10 because x is 5. So Python ignores this line, and then it goes ahead and it runs this line, right? So notice the difference here. This is printing done, this is printing yes. But why is it that Python will not print this one? Python will print this one. It's because of this something called indentation. Indentation is how we tell Python that this is a code block. This is a code block. Now, this is a single line of code, but this is a code block. Why? Because this guy is indented, which means it's under this guy. And we usually use this hyphen command when we are doing things. We are writing a code block, right? So this is kind of a standard process in programming. Then most programming are going to have different varieties of things like this with several if statements and maybe some other conditional statements that we are still going to get into. And sometimes you will have several if statements, maybe another if x 34, do something else, and we can continue to go like that. So we can even continue, honestly. So it's kind of like it gets complicated from here, So it can get much more complicated, So right here we are doing 5. Our primary line is, x is assigned to a variable x. 5 is assigned to a variable x. So Python remembers 5, and here it goes back and checks what the value for x is. It prints it to the console, and then it goes back here. It comes down here. It has to make a decision whether to go right or left. In this case, it needs to go. Maybe going right means printing what is inside here. Going left means ignoring here and continuing, right? So maybe if we have another code block here and say if x is equal to 5, then maybe print maybe we want to print Gotcha. All right. So in this scenario now, if we go ahead and we run this code, let's see what happens. We got 5 and we got done, right? And why is that? Because here, the variable x, Python assigns 5 to it. Here it prints its x, and that's why we got 5 here. And then it comes to here. Remember that Python reads the code from this side. So it takes 10, it compares it with x, and what we're telling it is, if x is greater than 10, then go ahead and run what is inside here. So it checks it. X is 5, which is 5 here, right? If 5 is greater than 10, obviously this is not true, right? So 5 is not greater than 10. 5 is smaller than 10. So Python doesn't do anything here. Even here, we give it another condition, but it never even enter this line to even talk about doing this one and continue. So this whole line of code, this whole place does not run because this guy is not true. 5 is less than 10. It's not greater than it. So that's why it leaves all this code, and then it comes to this one. Because this is another line that is not under any of these lines. So it goes ahead and it runs this one. That's how we got done, right? Now, what if we change it a little bit and we say, if x is less than 10, print x, print yes. And then if x is less than 34, okay, let me say greater than here so that we can continue to maintain the flow. So in this case, we go ahead and we run it. You see, we got more output on the terminal because here, okay, good. We assign 5 to x, and here we print it, so we get 5. Here, we check if x is less than 10, and this evaluates to true. So Python goes ahead and it gets into this line. So it prints x. That's why we got our second 5. And then it prints yes. That's how we got our yes. And then it reached another junction inside the first junction again. So it has to check whether x is greater than 34. Remember that our x is still 5. So x is greater than 34, right? X is not greater than 34. So this line evaluates to false. So Python ignores every other thing inside this line, and then it goes ahead, it continues to done. And that's how we got done. Make sense? Does anybody have any questions regarding what's on the screen? Any questions whatsoever? No questions. Oh, okay, we did have something in the chat. Someone says the thoughts is one of the bad words. Oh, okay. Yeah, if was one of the bad words, but when we use it correctly, you will see that it's not really bad word. It's more of reserved words. That's what we call them. So you will notice that Python names these guys, like our VS Code knows to color these reserved words. So when you use one of the reserved words, Python is, the VS Code is going to give them a specific color so that okay, this one is a reserved word. So the reserved words, they're not bad. They're just reserved for Python because Python have specific use for them. So like one of them is the if statement. Now we have now seen how Python use if. So it's kind of like the English way, the way that we use it, just like telling somebody, if you get to the junction, if my house is by the left, then take left, Yeah, but if my house is by the right, take right. I guess that's kind of like the way we use it, So that's how we use if statement. And you'll be wondering, maybe what's a use case, for this? It's actually pretty common that you'd imagine. Um, there is a time in my hold on a sec. Okay, we have another question. Does Python read code like a thread from top to bottom, or there are scenarios where you can do the computation before defining the variables? Great question. There is no scenario ever where you would write the logic before defining the variables. Okay, there is one scenario, but that's a more complex scenario that we'll get to later in the future, called functions. But let me use this one as an example, right? So if I go ahead and I print X, remember we're defining this variable in line 2 and we're printing it in line 1. If I go ahead and I run it, let's see what happens. Python complains, tells name error, X is not defined. Why? Because it tells us it's in line 1. So if we go to line 1, we see we're printing X. And Python, at this point, Python does not know what is X. If we are printing 5, that won't be a problem. Python can print 5. But because we are printing a variable, Python doesn't know what it is, so it throws up an error. So there are no scenarios whereby you will use a variable before printing it. The only scenario where you can do this is with functions. And in functions, it's kind of like a way for us to write some code and keep them and tell Python, hey, this is a block of code I'm going to use somewhere down the line. Just ignore it. Don't run it yet. Don't use it yet. Don't do anything with it. Just keep it. So in that way, we can have different functions that we wrote that does different things. Those functions are usually like, they are written to do specific things. Maybe you write one function, it does subtraction. You write another function, it does division. You write another function, it does multiplication. And then at some point in your code, you use those functions to perform multiplication, to perform addition, to perform subtraction. But Python is not going to use the functions you write until you tell it to use them. But that's a whole different scenario. We're going to get to that. I think we'll deal with functions on Friday by my own calculation. We'll get functions on Friday, I think, or maybe it's probably the next class. I don't quite remember. So yeah, good question, by the way. Nice catch there, Eugene. Do we have any more questions regarding this? No question. Okay, yeah. So I was telling you, so that there are actually like a lot of use case scenarios where you use conditional statements. So many of them, and it's kind of very interesting because in one of my previous roles, I was working for this. I was working for this airline company in US called Alaska Airlines, and we had some issues with underage. I think maybe they don't let underage people go alone on the plane or something like that. But they kind of need to know when the people who are booking the flights, when they are underage, kind of. So we needed to know that information. So we had a lot of meetings where these things were discussed, and at the end of the day, it comes down to my table, and my boss wanted me to take care of it, and then it was actually a simple Python code on the back end, that actually, kind of helped us fix that issue. So I will use that to give you an example, so that you kind of get an idea of what we are saying. So in my company, obviously, we have a website, we have a, a, a website that people will register and put their name and all their details, where they're going, and all of that kind of stuff. So, but at the end of the day, all that information people enter on our website, it all it all comes down to the backend. And I added a little bit of code that looked somewhat like this one. First of all, I needed to, let's say something like this. I needed to receive name, somebody, right? So name will be, let's just make it an input in this case. And it's kind of the thinking that's important, because programming is, is more about a way of thinking, and you getting used to it. So somebody needed to put in their name, and here I can say, maybe type in your name, right? The person can go ahead and type their name. And if I run this code at this point, it's just gonna ask me, what's your name? Maybe I'll say Austin. And that's it. We haven't told Python what to do with it yet. So maybe I'm receiving age as well. So we'll go ahead and tell you to input your age. Maybe I'll say something like, how old are you? And then the person, types in their age. So now I've gotten name of the person, I've gotten their age. And Python remembers this information because we assign them to a variable, right? And then the next thing I'm going to do is, because it's an age, I don't know if you, some of you were in the last class, if you're receiving inputs from user, you kind of need to deal with them properly. So the name is not a problem, because the name is going to be a string anyway, but the age is going to be a number. But remember that when we receive an input from a user, they are all strings. So we kind of need to convert them to integer. And what I mean is this. If I go ahead and I run this code right now, okay, let's say I'm printing it. Let's say I'm printing name, and I'm printing age. Let me go ahead and run it. All right, so when I run this and I type, maybe my name is Austin, and my age, let's say 20, it prints them for me. So the thing is this, if we wanted to know, this is a string, this is a number, but if you actually check their types, we use type in Python, remember, type name, type age. We run this. Okay, it doesn't, we didn't tell it to print it, but if we say print, and we tell him to print this one as well. Austin 20. So yeah, I just wanted you to notice that, remember that Austin is a word, that's your normal string in Python, right? The 20 is a number, that is your normal integer. But you notice that it tells us that the type here, we are printing the type name. The type is a string. And this one also is a string, even though it's a number. But I'm just trying to let you know that all the inputs you're going to be getting there, they are mostly going to be string. And we need to do type conversions. Remember, we've gone through most of this in our last class. So this is just a very good place a very good opportunity for us to actually see them in action, right? So I kind of need to convert this person's age to numbers, right? So, and how do I do that? So I'm going to put in another, I'm going to put in another line of code here. Let me put in another protocol here, and I said age equals to converting to integer age, right? So if we go ahead and we print types again after this point, and we run this code, and I put my name Austin, and I'm 20, and I run it, and we go through the code, you notice that first time that we printed the types, they were both strings. And then we converted it to age to integer in this line. And then we printed them again. And now only the name is a string while the age is an integer. So pretty important. You know, sometimes you run into errors in your code because of things like this. And another thing is, you know, actually, you know, when you're working with when you're working with like AI code generation tools like ChatGPT, for instance, it actually runs into errors like this pretty often, and you kind of need to go in and make sure that okay, because sometimes if AI is generating this kind of code for you, they might not really know what the user is going to type in. Like maybe this is not age, maybe this is something else that doesn't really tell us whether it's going to be a number or words. So the AI tool might not really put in this type conversion to convert the user input. So if the input is coming from a user, most times we don't really know what it's going to be, whether it's going to be a word or a number or whatever, there are many scenarios where we're asking users to put in information, and maybe sometimes it's numbers, sometimes it's words, So that's kind of a tricky situation where the human oversight is usually necessary, So you can run into, issues in your code, and it was perfectly generated code, from ChatGPT, and it still runs into an issue, and it's probably because the inputs that the users are typing in, it's probably not converted properly, right? So important stuff. So what we have done here is we have gotten, we've gotten a name, an age, and we've been able to convert them properly. So I'm going to go ahead and remove all of these guys because we don't need them. We usually do those things just for debugging and for learning, I guess. So I've converted the age, and now I'm going to show you how we use like the conditional statement to kind of make sure that people who are underaged, they are not allowed in, right? So here I'm going to give Python a statement, and I'm going to tell him that if age is greater than 18, then do something. This is small but powerful, but I know that, the underage, anything less than 18, that's underage. Remember our problem in the company is, we're having a lot of people register for our product. We'll need to know whether they are underage or adults, So if age is, then maybe maybe we are going to let them book their flights if they are over 18, and maybe if they are not on, if they are under 18, we'll not let them, or something like that. Maybe we want to make a decision, whatever, so, but I'm keeping it simple, right? In a real life scenario, we'll probably want to do something more, right? So, but maybe right now I just want to print something like welcome, you are qualified. something like that, All right. So, but what if the person is not over? How do we catch that, right? So there are many ways you can do this. You can actually use another if statement and say something like, if age is less than 18, maybe print, only adults allowed. We can do something like this, right? So if we go ahead and we run our code right now, and I put in my name, and I put in my age, and I go ahead, you see that I'm in. If I was registering on the company portal right now, my registration successful, right? Tells me how, it goes ahead, gives me the welcome message and all of that stuff. But what if someone else comes in and let's say Alice is 17? He goes ahead and he tells Alice, sorry, only adults are allowed. So this is a classic, example. And there are many ways that this can go, actually. Like I said, we can use two if statements. This is the simplest way to do it, but most experienced programmers will use maybe else. If we go ahead and we run this, it will work. It will work, Most people will use else if. Else if is basically another way of us saying, if this works, fine. Else, if it doesn't work, check this other thing, right? And then sometimes we can have a final thing that tells us maybe if both of them did not work, what are we gonna do? You say else. We can just say something like, for else statements, we don't really need to do much. We can say something like, can do something like this. Else. I guess we can just print something. Something like that, but in reality, there is not going to be any case scenario, where someone is not an adult nor underage, So, but it's just a way for us to see what are all the possibilities. In reality, when you're actually solving a real world problem, it becomes more clearer the things you need to put in your code and the things you want to kind of avoid. So, but I wanted to use this real world scenario that I experienced myself to kind of explain to you why we need all this, this if. Yeah. So I kind of wanted to show you, I've kind of introduced quite a number of new things in our today's lectures, I guess. So I kind of want to go over them and make sure that you're following. For instance, we have this less than and equal to operators. So these are, let me actually show you all of them. Let me go ahead and share this tab, internship day 4. Alrighty, so these are all the comparison operators. Remember, in some of our classes before, we saw these operators. We have the plus sign, the minus sign, the asterisk, for multiplication, division, and all of that stuff. So today we are looking at these ones. These are called comparison operators. much like the way they are in maths, basically. So this is your less than, and then we have something called less than or equal to. We have something called equal to, and we have another one called greater than or equal to. We have another one greater than, and we have another one not equal to. So these are all the comparison operators that we have, and it's a combination of these operators that allows us to do a lot of conditional statements, that we do in programming, right? These are actually all of them. Maybe there are a little bit more, maybe those are, ones, not things you're probably going to come across, but these are the ones you need to know for now. And these are the basic operators, much like the way they work in mathematics, but you notice that we now added some of these creative ones, like less than or equal to, equal to, for instance, equal to, funny enough, is not just an equal sign, it's a double equal sign. Why? Because a single equal sign in Python actually is an assignment statement. It's not an equal to, it's basically what we use to assign a value to a variable, right? So the actual equal to in Python is double equals. And we also have these things. And where do we need these things? Let's go back to our example, right? We'll kind of see how we can use some of these things in action, right? So I just wanted to show you guys, all the operators, so that you kind of have a visual memory of what they are and what they stand for. I'm going to try and use some of them in our examples right now. Let's actually see how we can do that. Let me go ahead and share my code once again. So remember, in this scenario, we're getting someone's name, we're getting their age, we're converting the age to integer. We're checking if the person's age is greater than 18, then they are welcome. And then if the person's age is less than 18, they are not welcome. But there is a small problem here. As a programmer, what if the person is 18? Obviously, if the person is 18, let's actually see it in action. So if I go ahead and I run this code, and I'm Austin, and I'm 18, you see what happens here? I put in my name, I put in my age. It comes here, it checks. 18, is 18 greater than 18? Obviously, no. 18 is not greater than 18. My age is 18. It's not greater than 18. So it does not run this guy. It comes to this guy. Else, if age less than 18, my age is 18. Now, is my age 18? Is it greater than 18? Is it less than 18? No. So this guy does not run as well. So it all comes down to this one. So this is a scenario where this our else now runs. But this is problematic because someone who is 18 is now an adult, right? So how can we make sure that the people who are 18 are also, that our code caters for them and not, like not remove them or go and do something else like he's doing here, telling us that we are neither an adult nor underage, because 18 is actually an adult, right? So in that case, what we can do is we can modify this line so that it uses the greater than or equal to sign. So what we are now saying that if our age is greater than or equal to, so in this scenario now, it's either 18 or greater than 18. So now if we run our code and then we put in our name and then our age is 18, we are qualified. So this is a classic example of us using this, you see, right? So that's one scenario that I wanted to show you, There are also could be things like, maybe like double equals. So if each age is equal to, that's when you're looking for people that are specifically 18, or if you're looking for people that are, that are less than or equal to 18, we can also do something like this. So these are all different scenarios where, we can use all these other more funny operators to achieve something. So you kind of get the idea of why we need all those other operators, right? Cool. So the other things that I wanted to, let me see. Python, where you got? Where are you? Okay. All right. So there are a few other things that I wanted to talk about. I was really hoping that today's session would be really short. But we have covered the main things. If you already reached this point, and you solve all this, all these problems with me the way I did it, you're but there are just a few other things that I wanted to point out. We already talked about the role of indentation, right? Python uses the indentations to define the blocks of code so that if an if statement it usually ends with the colon, and if statement will always end with colon. Many different types of other statements in Python will end in colon. It's usually a way for us to tell Python that there is an indentation coming up. Like the next line is part of the previous line, basically, right? So Python will work anything beneath indentation. It will always run it. There are other programming languages that there are other programming languages that they do these things differently. Like there are some programming languages that use braces to determine block of code. In those kind of languages, you probably need to whatever you want to put into this, maybe you need to put them in braces like this. There are some programming languages that does that as a way of telling the computer that these block of code are together. And then there are other ones that will have maybe a beginning and end mark at the end, like HTML, etc. So, but this is how Python does it. Just indentation, simple and short, and then it kind of makes sense because when you're looking at it as a human being, you will know that okay, this one looks like it's part of this guy. So indentation are very important. You can use the tab button on your computer to make indentations. You can also use 4 spaces. So an indentation is either 4 spaces or a bar, and a bar is typically 4 spaces anyway. So, but there are times where you can make a mistake, and then maybe instead of 4 spaces, you put in 5, and then Python complains, or maybe you are using tab as your indentation, and then you used spaces, so it's kind of a tricky situation that can get you into errors in Python. So it's very important for you to be very careful about your indentation. So you kind of make sure that if you're using your tab, just use your tabs. If you're using 4 spaces, just use your 4 spaces so that you don't run into issues. Most most um most code editors like VS Code, they already solve this. They already have a way of solving this problem. Maybe if you make a mistake, it will underline it with a red line or something like that. So, but despite that, it's something to be aware of, the role of indentations, right? And then we've talked about the comparison operators. We've seen the different operators that we have, like the equals one to check if two things are equal to each other. We've seen the less than, we've seen the greater than, we've seen the less than or greater than equal to. We also seen the one that is not equal to. There are scenarios where you only want a condition to run if it's not equal to. So the not equal to is also important, right? And then we have seen that you can actually have a conditional statement, inside another conditional statement, like we showed, like we showed by putting another if statement under this guy, for instance. So that's called nesting. If we have something like if age is greater than 18, go ahead and run this. And maybe we also want to sieve out people who are above 50. For instance, let's say people who are above 50 are maybe they are a special class, right? And then we can say if age greater than 50, then go ahead and do something. Maybe we want to give what we want to give like more senior people a different welcome message. Maybe we want them to, I don't know, feel superior or whatever. So we can do something like this, right? We can print a different welcome message for people who are above. Maybe we want to tell them, welcome. Right? Yeah, so in this scenario, if we go ahead and we run our code and I'm Austin, and let's say I'm 76. Okay, Austin, and I'm 76. We can see it goes ahead, tells me that I'm qualified, and then it also tells me that we love seniors on our platform. So people who are not above 50 will not receive the second message. This second message is only for seniors, So this is a classic scenario where we have, a conditional statement, and we have another continuous conditional statement inside it. So this is called nesting. We are nesting this, and all this block of code, they are all together because they are all inside indentations, right? So this is nesting. This is us nesting one conditional block of code inside another conditional block of code, And when you're writing real programs, it can get more crazy because you have nests and you have a condition inside a condition, inside a condition, inside a condition, and it's all this in a way for you to achieve the exact goal you want. So, but it's a system of thinking. It's how we think, and we program it into the computer, and then the computer mirrors our thinking, and then it brings out our desired results, right? So we have also talked about the else statement as well. We've talked about different direction. A common mistake that people usually make is writing multiple else if blocks, and where sometimes some of them are not even necessary, yeah, but I mean, I guess if you're writing code, just be careful with the conditional statement, because sometimes you can write you can write some conditions, and then maybe you have too many conditions that the computer becomes confused which one to follow. Maybe it just ignores some of them and it runs some other of them, and you might be confused because if you have so many conditions and some of them are true at the same time, it might run the first one and then the second one will no longer work, right? Let me just show you an example. Let me just remove this code and use this one. This is a simple code so that I won't be typing my name all the time. Okay, now we run into an issue. So we need to kind of define X first. In this scenario, X is 5, right? So if I run it, X is less than 20. And what's happening here? We assign X we assign 5 to x, and we say if x is less than 20, of course, x is less than 20, it's going to print less than 20. And then we don't say else, if x is less than 10, print less than 10. So you see, once this one is true, it doesn't get to this guy. So it only prints less than 20. It doesn't get to this guy. You know, if we were really hoping to do something here, to use this for something, you know, this line will never run because we're already giving too many conditions that are true at the same time, right? So you kind of have to think it through and make sure that the conditions you're giving, they actually make sense, right? So sometimes we have errors, you know, many times we have errors, all the times we have errors actually, and it becomes something like you cannot do without it. So they now came up with something called error handling, and they do it to as a way to kind of handle this, you know, all these ugly traceback errors that comes in, you know, like this one. It comes in and it's not pretty. Sometimes it doesn't really matter because now I'm the one writing the code, right? And I'm getting these errors. Fine and good, it's all good. But sometimes you're actually working on a real project and then you're done writing your code and then you send it to the company or you send it to your boss or your client or whoever, and they take that code, they deploy it to the public. Now, if any errors occurs when the code is already out and the public are using it, they're using the software you built there, they're using the app that you created, errors like this will no longer be pretty. It becomes a big problem because if any error happens, maybe a user type in the wrong words, the wrong values or whatever, your software runs into an error. You don't want to print this, you don't want the software to print this kind of error. So we usually handle it and try to make it look more cute so that the errors, the users can actually have an understanding of what's going on. And even you that is running the code, you can, you know, it makes it a lot more easier for you to handle the errors. So we use something called try and accept. For benefit of seeing it, we use this try and accept. Obviously, this is not how we type it, but I'll show you how we type it in a bit. So the try and accept is basically the same thing it means in English, I guess, because I mean in English, well, this is try. Accept is accept something happens. So it's kind of like we're telling Python, we will tell Python, maybe try this block of code. If it runs, good and fine. But if there is a problem, do this other thing, and then we'll put that thing and accept. So we'll normally say maybe something like this. Try this. You tell Python, hey, you know, try this. Except it doesn't work, try this other thing. So that's kind of like how it works. I'm going to show you that in action actually. Let me just go back to the previous example that we were working with. So remember here that we're getting inputs from user and we're getting their name and age, and we are converting this to integer before we use it, right? So let's say we go ahead and, you know, we run this code, right? And we put in our name, fine and good. I type my name, Austin, and then how old am I? Let's say instead of typing 20, which is my age, I type 20. Problem, right? And is there a way that you can stop a user from typing 20? No. Sometimes users want to break your code. Sometimes they want to try the limit of your platform to see how they can game the system. So users can actually type in whatever they like. Even though you ask them to type in numbers, they can go ahead and type in words. So, but what happens? They will get a very ugly error like this. And when it's your user, it doesn't look pretty. So we want to make sure that even if a user types something like this, we handle the error so that it doesn't look so ugly. So that's why we use error handling, right? Cool. So in this case, I'm going to put all this. Okay, let's see where our code is getting issues, having issues, having it at line 4, actually. And this is line 4. And line 4 is where we are converting our age to integer because we're expecting a number and we want to convert it to integer because it's a string. But then when our user went ahead and typed 20, it did not work because you cannot convert the word 20 to the number 20 by just using this integer type conversion statement. So that will not work. So we can actually go ahead and put this in a try block. Put this in a try block. And then we'll put another one. Except. We'll do something else. So maybe we can now do something like this. So now we have handled any possible error. And what we have just done is we have put a try block, and then we now put this thing under it so that when we now evaluate the age that people put in, Python is only going to try and run it. And if there is any problem, Python will just go to the next thing. And then it will go and print this. And then it will just give the user a hint of what's going on. Tell them that only numbers are allowed. Please try again. So let's go and run this code right now. And if we run our code and let's say I put my name, Austin, and my age is 20, but I don't want to put 20. So because I'm a strong head, so I just type 20, right? Okay, we still get a trace back though, but let's see what's going on there. So the first time we put our name, it gets our name. Type your name, Austin. Type your age. We type our age, and it tries to convert this. It obviously is not going to work, so it does go to this line. So it tells us only number is allowed. Please try again. So this part, we got it correct. It's working fine. But then it comes here and then it tries to compare if age is less than 18. That's line 9. And then it throws up an error because obviously we have typed in 20 and it's not working. So what we actually need to do is, okay, this is what we need to do. Because this code can break at any point, not just this line. We need to make sure that all these codes are inside the try block. So how can we do that? I'm going to take this guy out, and I'm going to just indent everything. Remember, once you have indented, they are all now inside the try block. And then I'm going to go ahead and, put my except here. So let's try again. I type my name, Austin, and I type my age, 20, and I hit enter. And now we no longer have ugly errors, right? There is still an error. Obviously, the error is still happening, but we have handled it. So this is a very, very important thing in programming. You come across this a lot. Maybe you're registering on a website and you type in your password and it goes ahead and it tells you, no, you have to include capital letters, you have to include lowercase, you have to include small special characters. You have probably come across things like that. This is how we do it, right? So in this scenario, even if the person type whatever they type, they're not going to be able to break our code. We only catch it. We're catching it, and then we're telling them, hey, only numbers are allowed. Please try again. So when they go ahead and they type the correct thing, let's say we run it out. My name is Austin and my age is 20, and I type it. It works correctly. It tells me, welcome, you're qualified, right? So this is the last thing that I wanted to talk about today about conditional. It's really that's really it. It kind of gets a little complicated, when we start getting into some other conditional statements like the for loop and all of that stuff. But we're going to deal with loops in a separate session. That should be the second to the next class, I think. So the next class we're going to be dealing with functions, and then the other one will deal with loops. We kind of bring everything together and write a full an actual Python program. Just kind of like a recap. Remember, if statements, that's how we deal with conditions. There are other ways we deal with conditions. We're going to get to them in a bit, but if statements, that's the standard. If you understand how if statement works, you're already on your way to be able to read, like 50% of all Python programs, honestly, because if statements are very, very, very widely used. We've also looked at indentations, how we use indentations to put code under another to kind of, tell Python that all this code that they belong together, right? We also looked at the difference between the assignment operator and the equals operator. It's kind of like a thing you need to know as a programmer because of the difference, because the equal sign, we use it as an assignment, and then when we actually want to do equals in Python, we now use double equal sign, right? So it's kind of a thing that you need to be aware of, right? We've also used the if statements. We have also used the else. We've also used the else if. We've also used how we can use if, under if, and we call that nesting. We have also seen how we can handle the errors gracefully and in a meaningful way that it's not ugly anymore to the users and they kind of have an understanding of what's going on. Honestly, if you're with me at this point, you're already a Python programmer, honestly, like you're already a Python programmer. There are just a few more things that you need to know to be able to, add Python to your, list of things, to be honest. So these are the building blocks of Python, and all the other big softwares that we build, they rely on these things, to make it work. So yeah, that's all of it. Do we have any questions? Okay, we are seeing some message in the chat. Let me see. It said, if I wanted to say people over 18 should get a message, but ones over 50 should get another statement, but not see the first one attached to the 18 group, how will you do that? Great question. Great questions. I like the way you're thinking, Eugene. Let's look at it. Actually, let's deal with it. So remember in this line, here we're getting a name, we're getting an age, and because we want the error to be pretty in case there are errors, we put them in a try and except block. So everything in the try, Python will try and run them, and only when they fail, that's when Python will come here. Right? And then Eugene is asking us, remember, when Python gets to this line, it begins to try. You know, it tries this guy, it works. Okay, this guy is above 18, fine and good. Okay, no, it assigns, it converts the age to integers, right? And then here it checks if age is, you know, is greater than, if age is greater than 18, we're going to tell them, hey, you're qualified. And if age is greater than 18, or but is greater than is greater than 50, we want to show them a different message. And then, but when we do this, we are getting this message and we're getting this message. We only want to get this message if they are above 50, and we only want to get this message if they are below 50, right? So how do we do it? So this is a little bit tricky, but I think I can solve this problem by just rearranging the code a little bit. So look at what I'm gonna do. First of all, when Python gets here, it goes ahead and check what's the age. Let's say my age is 20, right? It checks, is 20 equal to or greater than 18? Yes, it goes to the next line. But I don't want to print this message. So let me remove this message. So it goes to the next one. It says, is age greater than 50? Yes. If it's greater than 50, it's going to print this line. But if it's not greater than 50, it's going to ignore this. Remember, if the age is not greater than 50, it's just going to ignore this. So we can actually come back here and we'll put our print statement. This guy is trying to correct it for us. Now, this have solved our problem just by rearranging the code, because I know how Python reads it. So Python gets here. Okay, let's make sure that it works first of all, right? Let me run it. And my name is Austin and I'm 76, right? I run it. It tells me, how old are you? It tells me, welcome. We love seniors on our platform. But it also tells me, welcome, you're qualified. Okay. Now, nice. But we are still getting this message. How can we make sure we're not getting it? Now, we can further ahead, modify this guy so that it will say, if age is greater than 50, else. Do this one. Now, it's going to run this guy or to run this guy. So it will not run this guy and this guy, right? So let's test it again, see if we have solved our problem. So I put in my name, Austin, and I'm 80. And then it goes ahead and it tells me, welcome to our platform. We love seniors. And now we have solved our problems, right? So that's how we solve it, you know. So now it gets here, it checks, yes, our age is above 18, fine. So we can actually run this code. So it goes, it checks this one, our age is above 50. Oh, okay, so we can run this code. And once it has done this one, it stops. But if our age is below, it will not run this one. It will go for the else. So let's say we are 40. Okay, my name is Austin and I'm 40. It tells me, welcome, you're qualified. You know, but if I'm 80, it tells me, welcome, we love seniors on our platform. So this is very, very good. Actually, I think this is a very, very, very nice question. So, you know, you can go ahead and play with your code, like, and you know, try to build more features into it. And that's kind of how you build a software, you know. starting from simple things like this, you keep on adding things, make it more complex, make it do more things, make it cater to more different age groups and all of that stuff. Let's say, maybe people who are in their 30s, you want to tell them something different. You can go ahead and include all that logic into your code, and that's how your code keep on growing until it runs into thousands of lines of code. And as far as it works perfect, that's a whole software right there. So yeah, do we have any other questions? No questions. All right, guys, nice session today. Definitely go back and look at these recordings, and I'm going to find a way to make sure that people are coming to class, because we used to have more numbers in our classes until we started uploading the videos to YouTube. Yeah, I'm going to find a way to deal with that. All right, guys, nice to have the class once again with you guys today, and I will see you guys on the next class. All right, enjoy the rest of your day, and bye.
Good night, sir. Thank you so much.
Yeah, thank you. Yeah, have a nice day.